Hi folks, welcome to this video on higher order derivatives. We're working from the old textbook for IB, so that's the Hays Mathematics for the International Student 3rd edition. The derivative of the derivative is called, wait for it, the second derivative. And common notation would be y double prime or f double prime of x, or in the nice Leibniz notation it would look like this, d2y over dx2. Okay, and it looks weird there that the squared goes on the x on the bottom and not on the y on top, but there are good notational reasons for that I think will become clearer the more we get into some applications. Simplifying your first derivative, or maybe even the original function, can make it easier to find the second derivative. So if we find the first few derivatives here, hopefully we're getting pretty good at this. This first one's going to become 5 times 3x squared, so that's 15x squared, minus 4 times 2x, so that's minus 8x, and then the 2 becomes a 0. The next derivative would become 15 times 2x, so that's 30x, and negative 8x becomes negative 8 times 1. And we keep going, and we get 30 for the third derivative. This next one is going to give us a quotient rule. So if we get creative, if you have a monomial on the bottom, you can often avoid the quotient rule. I'm not differentiating yet. So this is 3 minus 2x to the minus 1. And if I differentiate, the 3 will become a 0. This will be negative 2 minus 1 x to the negative 2. Okay, because the power comes down front, power goes down by 1. I get 2x to the minus 2. I would leave it in that form if I'm going to differentiate again, because the next derivative will be 2 times power comes down front, power goes down by 1. So whereas initially we might have thought they all zero out eventually, here we see that some functions do and some don't. So negative 4, negative 3x to the minus 4. The third derivative is 12x to the minus 4. And we just follow our rules. There's some factorial stuff happening here behind the scenes. For this first one, or next one rather, we might rewrite this as x to the half plus e to the x. So the first derivative will be 1/2 x to the negative a half. And the derivative of e to the x is e to the x. So it just stays. Okay. The next derivative, the half will stay, it's a coefficient. The negative half comes down front, and the power goes down by 1. And we still have plus e to the x. I'll zoom in a little bit here. So that should probably be cleaned up. So we have negative 1/4 x to the negative 3 over 2 plus e to the x. And differentiating again is no big deal. Coefficients stay. Power comes down front, power goes down by 1, and there we go. Okay, and again, we should probably clean it up. So maybe I should put some breaks between which derivative I'm finding. So this will be 3/8 x to the negative 5 over 2 plus e to the x, unless I've done some sort of goof along the way. So we'll do one more here where we'll actually find a value. There's no way in this one to avoid a quotient. So u is going to be x, and v is going to be the bottom, which is x plus 2. That tells us that u prime is 1. Also v prime is 1. So hopefully this won't be too bad. So I'll get u prime. Let's just remember our quotient rule here. U prime v minus uv prime all over v squared. So u prime v minus u v prime all over v squared. All right. If you leave it like this, then it's going to be a bit of a pain for you to differentiate again. So let's see if we can clean it up. Gives us this. So f prime of x is 2 over x plus 2 all squared. That's a nice way of writing this. That's probably the most elegant way of writing it. But depending on what you want to do next, it may not be the most helpful way to write it. So you can leave it like that and use the quotient rule to find the second derivative. But what might be slicker is to think of it this way, just for the sake of differentiating. So that f double prime becomes, here we have a 2 stays, and essentially we have a glob to the power of negative 2. So we'd get negative 2 glob. Let me just erase a few things here. So we're going to find the derivative of that glob to the negative 2. So we break down the negative 2 times the glob, which would now be to the power of negative 3, times the derivative of the glob. And f double prime of x then becomes, I guess I should put in what those globs are, so x plus 2. And the derivative of x plus 2 is 1. Okay? So you might think, well, was the chain rule really happening? Yes, the chain rule is always happening. You might have gotten lucky in this case that you'd still get the right answer without writing it out properly, without remembering it. But it was not just x to the power of negative 2, it was a glob. And here at the very end, if you want to put it back in fractional form, you're welcome to. Okay? Either one of these are good, but neither one of them are the final answer. So finally, if I put in what it's asking me to, f double prime at 3, what is the slope of the slope at 3? I'm going to put it in just the exponential one. It would be 3 plus 2 to the negative 3. I'm not afraid of negative exponents. That means flip it and cube it. Okay, and I'll get negative 4 over 125 as my final answer. If instead I had done it from this form right here, okay, then I would get negative 4 over 3 plus, oh, that is unquestionably slicker. But you have to put in the work at some point. So either way, you're going to get the same version. You can check this out on your GDC, but you would first need to put in the derivative and then find the slope of the derivative. So this will be a little harder to check with your GDC. On page 382 of the old textbook, you could do page 382, numbers 1, 3, 5, 8, and 8. And then here's a little synopsis of what we've sort of done since we did first principles. So the derivative f prime gives us the slope of its parent at any point. Simple rules for differentiation spare us from first principle. What's in bold, always look out for the chain rule. Okay, and also look out for the product and quotient rule. If a function involves logs, you may be able to use log laws to rewrite. Also, the song has the chain rule built in. So if you're going original on the bottom, derivative on the top, chain rule is built into that. You don't also then need to look for the chain rule again. To find the second derivative, take the derivative of the derivative. There's a whole ton of rules here. Some of them are written with the chain rule showing, but I'll show you what you're actually given in your formula booklet. Here we are. At SL 5.3, you can see derivative of x to the n. Then there's some integration stuff that we'll get around to in the not-too-distant future. And then there's the derivative of sine x, cos x, e to the x, ln x. The chain rule, written however helpfully you find it there. The product rule, written as uv prime plus vu prime. And the quotient rule, written as vu prime minus uv prime all over v squared. Again, I would memorize most of these because there's not a ton there. So at the top of the screen right now, there's the practice with second derivatives. At the very bottom, if there's stuff that you want to do on review sets from that old textbook, there you go. I hope that you found this helpful. Good luck with the material, folks, and take care.